Just to introduce you guys probably don't know me, but my name is Brad Engel, and I work with the specialty division. So we're the guys that make micronutrient specialty fertilizers. And really my job is to go out and promote our products in the states of Michigan, Indiana, Ohio, and Kentucky. That's my trade territory. So what I'm going to get started with, the title is actually plant stimulants. Most of what I'm going to talk about today is actually micronutrients. Fully applied micronutrients and the way we can use those to stimulate the plant. So just to get started, lay the foundation here. What I've got, this is Mr. curve, okay? So this is your standard yield curve, okay? So as you apply any fertilizer, your yield and disease resistance increases. So this is the dotted line, basic yield curve here. So idea here is that we do not want to be on this end of the yield curve, okay? We don't want to see deficiencies in the field, number one. Number two, we don't want to be in this hidden hunger area. So hidden hunger is known as a transient nutrient deficiency, okay? And when that occurs, basically 2 times during the growing season. Anytime we're doing rapid vegetative growth, we can see this hidden hunger, and also the transition stages, when we go from vegetative to reproductive stages. We also can be in this hidden hunger area. So again, don't want to be in the hidden hunger, definitely don't want to be in deficiency, okay? So at Brandt, we are not in the business of solving or curing micronutrient deficiencies. We don't want to see any deficiencies in the field from the get-go. So if we're on this end of the curve, we've already lowered our yield potential. Moving on, basically what we're looking at here is removal rates. So 200 bushels of corn, 70 bushels of soybeans, okay? And this is the pounds per acre that we're removing in the grain. And the take-home message from this slide, guys, is that I think we're doing a pretty good job with our macronutrients and secondaries, okay? So we're doing good with the NPKs, also doing good with the calcium, magnesium, with our liming practices. But the one that we're kind of missing with all that is the sulfur. So that takes me to the next slide down here, which is the striped corn. You guys probably saw some of this early this spring, cool, wet weather. And not really sure, when you go out and you see the striping in the field, is it sulfur deficiency? Is it magnesium, zinc, manganese? It's really hard to tell. And I've been in fields with, I've seen striping like this and been 100% sure it's sulfur deficiency. So go ahead and pull a tissue test, send it out to the lab, comes back, yeah, it's deficient in sulfur, but you're also low on zinc and manganese too. So you can kind of hide other nutrient deficiencies. Reason we're running into sulfur deficiencies, we're not getting free sulfur from the rain like we used to. Okay, the Clean Air Act worked. Back in 1989, we used to get about 10 pounds of sulfur, basically free sulfur from the rain per year. Clean Air Act, they put the scrubbers on the coal plants and basically removing the sulfur from the emissions. So we're not getting that free sulfur from the rain we used to get. So you guys can thank Al Gore for that. Okay, but so this would be the reason that we're starting to see more sulfur deficiencies out in the field. Basically, when we think about what we're going to do for sulfur, we've got 3 options. We've got elemental sulfur, so it's a 90% sulfur dry product that we can blend in with our fall applications of DAP, potash. Problem with 90% is it takes a while to break down, okay? It can take like 30 to 60 days to break down, and you got to have the proper temperature and proper moisture. So it's really not going to start breaking down. If you go out and fall apply it, it's not going to start breaking down until next spring. Product we like at Brandt to use is a product called ATS, ammonium thiosulfate. It's a 120026 liquid product. And the way we use that is with our pre-emergent herbicides. Okay, we're going to mix 28 plus ATS with the pre-herbicides and go out and do a weed and feed prior to planting. Other form of sulfur that some guys have been pushing, kind of talked about this. We had a pre-field day meeting and kind of came up was guys were talking about using AMS fall applied, so plain ammonium sulfate fall applied. And I want to tell you guys that as far as sulfur, that is not the way to go. Reason being, you know, if we think about the way we do nitrogen, if we fall apply, we're going to fall apply ammonia, right? Because we know it's going to stay. We're not going to apply nitrate form of nitrogen in the fall because we know it's mobile. Sulfate form of sulfur in the fall, 50% as mobile as nitrate. So if you're applying ammonium sulfate in the fall, your sulfur's gone. Okay, it's going to leach through. From there, I'll take you guys into micronutrients and talk a little bit about that. Basically, what I've got here is some data from research done at Iowa State in 2011. And what they did, they looked at the pounds of removal, zinc, manganese, and boron, as yields went up. So as soybean yields went up, we took more zinc, manganese, and boron, you know, in the crop from the field. Same thing with corn over here, but what's different about this corn curve is it's a curve, okay? It's not a flat line. So we get to 250, 300 bushel, it's an exponential curve. We're taking even more micronutrients from the field. So as you get into those high yielding environments, soybeans, especially corn, there's a bigger demand for micronutrients. Two premier products that the specialty group has for micronutrients, we've got Smart Trio. This is a zinc, manganese, boron combination, also has sulfur in it. And then we've got this product called B-Moly, combination boron, molybdenum. And we've also got a product related to B-Moly, just plain in boron, basically without the moly in it. Some yield data here. This comes from the Brandt Research Farm down at Pleasant Plains. We're looking at 1 quart of Trio with our post-applied herbicides at 1 quart to the acre. And we've got years of data here, and then an average on the end. But important when I show you guys this, that this is not one combination or one comparison. Okay, this is Trio, multiple corn hybrids, different planting dates, different populations, different fertility levels, and we're putting that all together, you know, with and without Trio. What are we seeing? So like I said, a 4-year average of about 12 bushels to the acre on corn from the Brandt Research Farm. What I thought's really cool is, I told you guys I covered the states of Kentucky. So the guys at Southern States is a big distributor of ours in the state of Kentucky. They did a similar study last year on their research farm in Franklin, Kentucky. So looking at Trio with different herbicide, fungicide combinations, and what their average was 12 bushels. Okay, exactly what we're seeing down in Pleasant Plains. Other thing is, you guys can see these numbers. They have a hard time raising corn in Kentucky. Okay. Looking at yields in the 60s to 70s. So obviously last year they were very affected by the drought. So you guys should feel very fortunate that you're, you know, raising corn here in Illinois and you're not down in Franklin, Kentucky. But these guys are very pleased with the Smart Trio, and you know, if they're happy that they're going from 60 to 70 bushels, you guys should definitely take a look at it, you know, if you want to go from 200 bushel to 210 bushel corn. Moving on to the B-Moly product. This is going to be the product that we're going to like to use at harvest stages, both corn and soybeans, okay? So we're going out with fungicide or fungicide-insecticide combination. Number one, for legumes, in order for rhizobia bacteria to infect the root, you have to have adequate boron there. Okay, if the rhizobia goes to infect the root cell and there's not sufficient boron, basically the cell will lignify itself and prevent the association from forming. So have to have boron for nodulization. Okay. Other thing, we've got some moly in this. Moly is very important for nitrogen metabolism. Okay. So this reduction reaction, basically the metabolism of nitrogen and move into the grain. Okay, so we're taking carbohydrates and nutrients from the soil, carbohydrates from photosynthesis, moving that into the grain. boron, moly, very involved in both those processes. That's why we like these at the R stages. So if you think about soybeans, we hit R1 on soybeans. We've only taken up 20% of the nitrogen that we need to take up for that crop that year. Okay, so idea behind this is we hit R stages. Let's give it a shot of boron, shot of moly, keep those nodules happy, okay, and fix the nitrogen and helping those fill pods. Some boron data. This is on corn. This is the N boron. 7 years of data going out with the fungicide, okay? And what we're looking at is a boron fungicide combination at tassel on corn. And you can see across the board we've seen really good yield responses. A question I normally get when I show this slide is, you know, what am I getting the yield response from? Is it the boron? Is it the fungicide? The answer is it's really the combination of the two, okay? So I had to go back and dig in the data, but this is data from 2006. We looked at two different fungicides, headline and quilt, and the red bars are basically an untreated. Gold bar would be a fungicide. Black bar is a fungicide boron combination, okay? And really we're seeing a synergistic effect when we add boron to a fungicide. It's kind of a 1 + 1 = 3 effect. So like I said, boron very important for soybeans, also for corn. We think about corn and nitrogen. Once you hit R1, VT R1, you've taken up actually 80% of the nitrogen that you need. So what boron's doing for corn is helping move nitrates from the leaves, from the plant, into the grain, okay? A lot of guys like to use slow release nitrogen at this stage with fungicides. If you've already taken up 80% of your nitrogen by VT, you're really kind of missing the boat as far as nitrogen. But it definitely makes sense for a boron application at that timing. Pipeline trials, basically we're looking at experimental products, okay? And anything that wins down here on these pipelines or looks good, we're going to go ahead and we're going to bring it up to this farm and look at it in Pleasant Plains a second year, okay, and in more detail. So just a snapshot of what we're doing down there. Basically looking at micronutrients plus things like photosynthetic enhancers, PGRs, plant growth regulators, both by themselves and in combination. I went out and we see some drastic crop responses early in the season. So I went out 24th of June, and basically we dug some plants or chopped them off actually at the soil surface and tried to capture really what we're seeing in the field. The next three slides, anything you see on the left is going to be just a control, okay, untreated check. To the right is where we've got the experimental products. So this one is just a PGR by itself at V5. And this one, man, I tell you what, if you were going to go and drive by and look at this field, you'd pick this one out. Taller than all the rest of the corn, looks great. But when you notice when you cut it out, basically what a PGR is doing, this one especially, is stretching the inner nodes, okay? We're going to lengthen that crop. Looks great, but you know, is that going to yield at the end of the season? Is that going to fall over because it's so tall? We don't know, but we're going to take it to yield. This is the PGR in combination with the micronutrient. And so again, control over here, PGR plus a micronutrient foliar at V5. Right there with the PGR by itself, but if we look at the inner nodes, we haven't stretched them out, okay, we stacked them. Final treatment I want to tell you guys about, this really isn't an experimental treatment, but it's one that looked darn good to us when we were out there, so we decided to go ahead and take some pictures of it. Application time is wrong on this. This is actually at planting. So this is 1 quart of an EDTA zinc and 5 gallons of ATS, okay? And this is going down with the planter right behind the closing wheels. So I know this is, you know, not for everybody if you're not running starter fertilizers, but something to think about if you are or if you have that capability. Again, really look good. Starting all the way at that V4 stage, you could pick this one out as the best looking corn out there. fully expect it to be the top yielding experimental product we're looking at too. So.
Okay.